Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about how this scheduling approach, that is earliest deadline first in CPU scheduling algorithm works. Basically, if I talk about earliest deadline first algorithm, it is an optimal dynamic priority scheduling algorithm which is actually used in real-time system. Okay, it can be this EDF users priorities like T1, T2, and T3, that is a process, and to schedule the jobs, and it assigns priority to the task according to the absolute deadline. You can see the deadline over here. It is just an introduction. Slightly, I'm giving the introduction before I'm getting into the topic. The task whose deadline is closest gets the highest priority. Say for example, here the task of deadline for T2 is little lower comparing to this T1 and T3. So the priority are assigned and changed in dynamic fashion. Okay, so let's say why this EDF is very effective, because compared to the other scheduling algorithm in real-time system, it can make the CPU utilization to the 100%. We are going to check that when we are going to have the proof of that, while still guaranteeing the deadlines of all the tasks. So that is the main objective of this earliest deadline first algorithm. Okay, so let me get into the topic directly. Now you can see here T1, that is a task. We can call it as process also. These are all the process T1, T2, and T3. And this runs in the capacity of 3, 2, and 2 respectively. And this capacity have a deadline to be executed on 7. The deadline for T2 is 4 and deadline for T3 is 8. And this deadline has a period of completion, that is 20, 5, and 10. So here, say for example, we are going to take the period here, and let's take the period here. It is 20 and 5 and 10. So for example, if you take a LCM of that, we can have the periods of T1, T2, and T3 respectively. We'll have a maximum of here, it is 20. So let's say we are going to take the period of 20, right? So I have drawn three different lines here. That is a vertical line. You can see that it is called as a period of execution. T1 executes a period of 20. You can see here, this is the task and deadline and capacity assigned. So maximum is 20, and second maximum is 10, and third maximum is 5. So accordingly, we are going to draw this. Okay, so say for example, I'm going to take this T1, and it has a capacity of 0, and it ends at 20. So this is the maximum capacity of T1. And T2, right? If you can check this T2, it starts with 0, and the maximum value, we are already find the LCM of this. So the maximum value is 20. In between, you can check that the deadline is 4 and the period is 5. That means between this 0 to 20, it has been divided into 4 different parts. Why? Because the period of years, you can check the deadline here. So the deadline for T2 is 4 and the period is 5. So that means this T2 task will take a capacity of 2, and it will execute until the period of maximum period of time. So the maximum period here it is 20. So we are going to split this accordingly. So say for example 0 to 5, and 5 to 10, and 10 to 15, and 15 to 20, right? So this is for T2. Let's say what is this T3, and what is the deadline for this T3. So deadline for T3 is 8. Okay, so it can be, and its period is 10. So in between this 20, this T3 can be executed for 2 times, because its deadline is 8, and 8 plus 8 16, and here the maximum time period what we have is 20. So this is how it splits. So we are going to check the maximum time here, that is 0, and we are going to split that with again 10, and here it is 20, right? Let's fix the deadline for each and every task. So here let's start with this T2, and T2 deadline is, I will draw in a different pen so that you can understand. T2 deadline is 4. You can check that here. It has been clearly given. T2 deadline is 4. That means the capacity should run before the deadline. Got it? So the next deadline will be 4 plus, that is 5 plus 4. Again it is 9. Again it starts here 10 plus 4. Again it is 14. Again 15 plus 4. Here it is 19. I hope you understand how this values has been assigned here. See here, 0 to 5 is a maximum period, right? But this capacity for T2 will have a deadline called 4. And the 4 has to be splitted everywhere in this particular travel. So you can check that 0 to 4. Again it starts with 5, 5 to 9. So 5 to 9, the deadline is 4. So every time the deadline splits, the maximum deadline it can reach is 19, not 20. Okay, so that is T2. Let's see what is this deadline for this particular T1. So you can check it here. Deadline for T1 is 7 and the period is 20. So 0 to 20, the period it can execute is, that is deadline is, so say for example here it is somewhere 7 and it can execute the capacity of 3. Okay, and the time period is 0 to 20. That means it is executing only once. Okay, now T2, let's fix the capacity here. So 0 to 4, that is the deadline here. You can check it. 0 to 4, it executes the capacity of 2 units. Again 5 to 9, 2 units. 10 to 14, 2 units. And 15 to 19, 2 units. I hope you understand now how exactly this process has been getting. Now T3, you can check the T3 and the deadline is 8. So we'll fix the deadline here it as 8. And 10 plus again 8, 18. So that means the period of this particular T3 is 10. So we have a maximum time period is 20. Why? Because we have 3 tasks and the maximum period for a task is 20 and all the task has been separated accordingly. So we found that by doing an LCM. So here you can check it 0 to 8. What is the capacity here? It execute 2. 0 to 8, 2. Again, it starts from 10. 10 to 18. Again, what is the capacity? 2. Right? So this is how the split has been done. Right? So now you can check it. So this we used to call it as a Gantt chart in the previous algorithm, that is FCFS and SJF, round robin and all these things. This is a different kind of it's a different kind of chart where you are going to check how this earliest deadline first algorithm scheduling works, right? So now you can choose here which task has to be performed first. It was chosen based on the minimum deadline. So you can check it. Minimum deadline is T2 and the next minimum deadline is T1 followed by T3. So we are going to follow this one by one based on the deadline it has, right? Now you can check it. Now we are going to take it. Let's say for example we have already drawn T2 has 0 to 4. That is 4 is a deadline. Before that, what is the capacity of this T2? It takes only 2 units to complete the task and it is completing before the deadline. That's a point, right? So earliest deadline first, that is the meaning of it. So it takes from 0, you can check it, and it runs for 2 units. So T1, right? So whenever you complete, whenever each and every process completes, I'm going to tick that so that you can understand how exactly it works and which are all the units, that is a capacity of process has been completed, right? Now again, we are going to check the next one, right? So sorry, this is not T1, this is T2, right? We are going to check that. Mistakenly, I have made it as T1, right? So the next process is, that is next task is, as you all know, we have checked this as first, this as second, and this as third. So based on the deadline, we have been allocated this. So the next task is, we are going to select T1 because its deadline is 7, right? You can check it. Now T1 is executing for how many? What is the capacity of unit? It is 3. So here you can check it. We are going to travel from 2, 3, 4 and 5. So totally T1. So here it is 2, here it is 3. For example, you don't want to mention when you are writing your exam. This is for your understanding, right? Just mention how many units it has been traveled. So now this T1 is completely over. Why? Because this T1 is a time period of 20, you can check it, and the capacity is running for only one time. So this process is completely over. So after completing this, we have a third priority. What is the priority? Is T3. This is the third one. So T3 is completing that for 2 times. You can check that. This particular process is very important for deriving this chart. So T3 comes here. T3 is exactly running it for 2. That is a capacity of 2 units. So it starts from, for example, 5, 6 and 7. 2, right? 5 to 6, 1, 6 to 7, 1. So totally 2. This is 2 units. So which task is completing here? T3. Right? I hope you understand how exactly it is working. Now let's get into the topic. Like now T1 after T3, again T1 comes, because T1 has completed only one repetition, and T2 has completed only one repetition. T1 has completed the whole thing, nothing left to do here. T3 completed one and one more left, right? So based on the priority, we have the next shortest deadline is again 2. We are getting into 2 now, right? So now 2 is going to be executed. T2 again, it is going to run the capacity of 2. So you can check it here. So it takes exactly from 7 to 8, 8 to 9, the capacity of 2. So which task is running here? T2. It's very important to mention which task is running here, right? So after that, within a deadline, you can check it, within a deadline 9, it is completing its 2 tasks, right? And also you can check it, T3 within a deadline of 8, T3 it is completing at 7. You can cross check this, right? That is the reason we made this. Now say for example T1, what is T1? What is the deadline for T1? 7. So you can check here, T1 within a deadline of 7, T1 is completing exactly before the deadline. It completes at 5. So deadline is 7. Do you understand? So this is how this earlier deadline first is working. So let's see, let's complete the task. So 2 process repetition has been over here. After that, you can check it here. Now comes the check. Let's see, what is this particular thing? 9 to 10. See here, again we are going, T2 is completed. Again we are going to T3. T3 exactly starts the next repetition from 10 to 18. Right? So that here we should not start from 9. Again it runs for 2 capacity. No. So if it is starting from 9, then you can check it. The deadline is 8. 9 is idle. 10 is also idle. From 10 onwards it has to be started. I hope you understand. Right? Now say for example, T2 is again having this particular idle time. So in this idle time, which comes first? Say for example, the deadline here it is, you can check it. Here it is 9, here it is 8. After this 8, this T2 is having a repetition starts from 10. But here in T2, the repetition starts at 9. That's the point. You got it? So it ends at 9. Again, it starts at 10. So now which process is executing here? T2, not T3. That is the one particular point you need to understand over here. Right? So we have a gap here between 9 to 10. Again, T2 is taking here and it is running for capacity of 2. Right? So this is how T2 enters based on this earliest deadline. Now again this T3 is coming inside. See here, you can check it over here. The deadline is here, it is 8. After that, there is a pass. Here the deadline is 9. Deadline is 9 for the previous one. Again it immediately starts from 10. But here the deadline is 8. Again it takes 2 repetition to start. That is the reason this T2 is getting inside. Hope you understand. Right. So the next process is T3 is coming inside. Now 3 repetition is over for T2. Okay. Now the next repetition again starts. So still one more capacity is left here, and the time period is also. So it starts from 12, and the deadline, you can check it, it should end before what is it, like 18. So here the deadline is 14. So that is the reason this particular T2 brought in here first. Okay, say for example, if this particular T3 is running here, right? So there is a doubt, there must be a doubt for you people, still wonder why this fellow is talking about why this T1 is coming in, T2 is coming inside instead of T3, because before that T2 has completed, now the repetition goes to T3 now. The reason is the deadline for this T3 is 18. If it starts run from 10 to 18 here, you can check the 18 I have mentioned down, there is no space here, that's the reason. If it's still running, but this repetition, that is T2 repetition for this particular third repetition cannot be completed by T2, right? That is the only main reason. Now let's start here. The capacity for this T3 is 2. So 12, 13 and 14. So this is T3, capacity is. Now what is the final thing left over here? You can check it. So here it starts with 15. You can check it over here. And the repetition is 15 to 19. Before 19, this particular T2, the task has to be completed. Okay. So it takes again 14, 15, sorry. Yeah, exactly it is. So there is a process here. So the repetition again starts from this 15. You can check it here, 15. So it starts from 15 and it ends exactly at 17. So this is also completed before the deadline call 19. So which task? T2, and the capacity is 2, right? So this is how this algorithm has been made, and this is how it is used to call it as most effective algorithm in CPU scheduling. So basically this algorithm is always includes the kernel overloaded, and the usage is less than 100%. That means that all the tasks have met the deadline. You can check it here. All the tasks has met the deadline. That's a point here. And each and every, that is earliest deadline first, finds an optimal feasible schedule, right? So this is how this algorithm has been designed, and very carefully we need to draw this particular chart, which has a reference chart here. We have already drawn the reference chart. This reference chart, we need to be very careful, and doing this we need to calculate the period. So period is clearly given here. You can check that for task 1, 2 and 3. You can call this as process also. And each and every process task you need to analyze, take an LCM. This is my method. And the capacity you need to note, deadline you need to note, what is the period for that. So everything will be drawn before drawing this chart. Thank you.